What is O Math World? I'll tell you what is O today, and that is inverse trig functions, okay? And specifically in this video we're going to be talking about the inverse of the cosine. So the first thing we want to do is let's look at a graph of the cosine. Here is f of x equals cosine x. Let's remind ourselves briefly here what an inverse function does. Let's say we have f of 0, and we know here that f of 0 equals 1. That is, the cosine of 0 is 1. Okay? Well, f inverse, let me change colors on that. F inverse of 1 then equals 0. That is, the inverse function is the function that takes the output and sends it back home, sends it back to 0. Okay? Let's see, f of pi, let's say pi over 2. F of pi over 2 is 0. That is, the cosine of pi over 2 is 0. So, that's going to imply that if we have an inverse function, f inverse of 0, so it's going to take that output and send it back home. F inverse of 0 equals pi over 2. Now the problem is, kind of glossing over something here. The inverse function is a function. That is, it's the inverse function, and thus it is a function. So let's look back here at this one. I said f of 0 equals f inverse of 1 equals 0. So let's think about that just a little bit more. F inverse of 1. So f inverse of 1, that would ask you, and if my function was cosine x, that would say, for what values of x is the cosine equal to 1? Well, the cosine is equal to 1 at 0. It's equal to 1 at, what, 2 pi. It's going to be equal to 1 at negative 2 pi. And we could find infinitely many more values where the cosine of 0 is 1, because it's a periodic function. It's always repeating itself. So, over the course of history of math, mathematicians, scientists, engineers all agreed that we want an inverse function for the cosine of x. But we have to limit the function to a domain where it is 1 to 1. Okay? So, the agreed upon domain here is going to be, you look here in red, when you're thinking of the cosine and with respect to its inverse, this is the only portion of the graph that you think of. This little 1-to-1 piece here that runs through all the values of the cosine. It goes from negative 1 to 1, and so it runs through all the values, and it is 1 to 1 on that little piece. Okay, that is, we restrict f of x to the domain. Let me do it in red since I graphed it in red there. Restrict it to the domain is 0 to pi. Okay? So restrict it there, and then we can have an inverse function that doesn't have us given something that's supposed to be a function and given more than one output for individual inputs. Let's look at this formally. Okay, so for t in the interval -1 to 1, the arc cosine of t, denoted cosine inverse of t, is the unique angle in 0 to pi whose cosine equals t. In other words, the equation cosine inverse of t equals theta means theta is the unique angle in 0 to theta such that cosine theta equals t. And boy, is that a mouthful. Let's look at one of them. Let's do a problem here. So let's say we want to look at the inverse cosine. The inverse cosine of what, 1/2. Okay? So here that tells me that it's the unique angle from 0 to pi whose cosine equals 1/2. So I'm trying to find, I need theta, some angle theta in the closed interval 0 to pi such that cosine of theta equals 1/2. Okay? Let me draw a circle. So we're looking on time, looking good right now. Draw a little circle here. Okay? It's a pretty little circle. Okay, so we need to know, when is the cosine going to be equal to 1/2? Well, the cosine equals 1/2. That's my 1/2 mark right there. Okay, so it's going to be up in that angle there. Okay, so that angle is going to be what, pi over 3? Okay, pi over 3. And note that for t and the arc, this right here really restricts my, when I'm talking about the inverse cosine, I'm talking about this arc right here. So everything's going to come from there, 0 to pi. Okay? And let me say one more thing about your book doesn't use this much, but I really like it, using the arc cosine to name this function. That is, I'm going to repeat this problem right here, but I'm going to call it the arc cosine, arc cos of 1/2. Now the reason I like this is because to me this says, give me the arc such that its cosine is 1/2. I mean, it clearly tells me, that is, I want the arc length on the unit circle such that its x coordinate is 1/2. And we know when we have an x coordinate of 1/2, we have a y coordinate of √3 over 2. Okay? So that's going to give me my pi over 3. Let's do a couple more problems here. Inverse cosine number 1. Inverse cosine of 0. Okay? Draw a circle. And when is the cosine 0? Well, the cosine is 0 right there. So that's going to be pi over 2. I think we've already done that, didn't we? Pi over 2. And it has to be between 0 and pi over 2. So number 2, inverse cosine is 1. Okay, again. Draw a circle. When is the cosine 1? Well, it's right here is when the cosine is 1. So that's going to equal pi. Equals 0. Number 3. Hold on, give me 1 minute, Paul. I'm almost done with this video, buddy. Explain why the inverse cosine of 2 makes no sense. So, cosine inverse of 2. That would mean I need theta such that cosine of theta equals 2. Well, we know on our unit circle the cosine, unit circles of length 1 here, a radius 1, and the cosine is the x coordinate. There's no x coordinate on the unit circle that's going to have, I mean, there's no point on the unit circle that is going to have an x coordinate of 2. Okay? So we cannot have the inverse cosine of 2. And if we look back here, it's not in the inverse cosine of 2. 2 is also, you could just say 2 is not in the domain of the arc cosine. Okay? Next video, we will be talking about the inverse sine function. I will see you there. Cheers.